Hello friends, welcome back. In my previous video, I have explained evaluation of double and triple integrals by using the problem evaluate integral 0 to 3 integral 0 to 2 xy into x plus y dx into dy. So to understand more about this, let us go with some more problems. So now I am going to solve second problem on this concept. So your second problem is evaluate integral 0 to a integral 0 to b x square plus y square into dy into dx. So this is the given problem. So let us write its solution. So given is I integral is equals to integral 0 to a, second integral is from 0 to b. The given function is x square plus y square into dy dx. Yes, you look at the problem and try to identify the limits. So the given limits are from 0 to a and 0 to b. It means that both are constant limits. So when they are giving constant limits, you look at the order of integration on the basis of your variables dy and dx. Here they are given dy and dx. It means that first you are integrating with respect to y, then with respect to x. Therefore correspondingly you can identify the limits of y and x. So first you are integrating with respect to y means of course 0 to b are the y limits and 0 to a are the x limits. So let's integrate this. I is equals to integral 0 to a, within bracket you are writing integral 0 to b function x square plus y square into dy into dx. I is equals to integral 0 to a. Now first let us integrate with respect to y. So y means your first term contains x square. So x square you are treating as a constant. So x square you are writing as it is. Therefore if you take x square outside, 1 into dy. 1 into dy integration is y. Therefore first term x square integration gives x square into y. The reason is we are making use the formula 1 into dy gives y. Then plus your second term is y square. So obviously y square integration is y cube by 3. So it will take the limits from 0 to b into dx. Now let us use limits in the given function integral 0 to a. Here we are treating x square as constant, you keep outside. In place of y we are making use of the upper limit b and lower limit 0. So in place of y, first of all you are writing the upper limit b minus your lower limit. Lower limit is 0. In place of y you are writing 0. Okay. Plus in second term is y cube by 3. Y cube by 3 means you treat 1 by 3 as constant. In place of y cube you are putting upper limit and lower limit. So in place of y cube you are writing b cube by using the upper limit b, and minus in place of y cube by using lower limit you are writing 0, okay, into dx. So if you simplify this, I is equals to integral 0 to a. So x square into b is x square b plus 1 by 3 into b cube. This is the resultant function. This we shall integrate with respect to x. So x means you treat b as constant, so x square integration gives x cube by 3 plus b cube by 3 is constant, integration of 1 into dx gives x. Here the applicable limits are 0 to a. So upper limit of x is a and lower limit of x is 0. I is equals to, now b by 3 is constant, in place of x cube we are making use of the limits. So first upper limit is a, so in place of x cube you are writing a cube, lower limit is 0, in place of x if you put 0, a cube minus 0, plus in second term b cube by 3 is constant, in place of x you are writing the upper limit a, minus in place of x if you making use of the lower limit you are getting 0. So finally if you simplify, so a cube b divided by 3 plus a b cube divided by 3. So if you compare these two terms in numerator and denominator, so in numerator ab is common and denominator 3 is common. If you take ab by 3 as common, so you are getting a square plus b square. So therefore your answer is I is equals to ab divided by 3 into a square plus b square. So this is the method when they are giving direct constant limits. Now we shall look at the problem when they are giving variable limits. So let me consider another example. Evaluate integral 0 to 4 integral 0 to x square, and the function is e power y by x into dy into dx. Now let us integrate this function. Solution: given integral you take it as I is equals to integral 0 to 4, second integral from 0 to x square e power y by x into dy into dx. Now if you compare this problem with the previous problem, what are the differences? So if you look at the first integrals, so first integral limits are from 0 to 4. So 0 to 4 means constant limits. Let us look at the second integral, 0 to x square. Lower limit is 0, of course it is a constant, but upper limit is x square. X square means it is variable limit, not a constant limit. So means whenever they are giving variable limits, so we need to identify what is the order of integration. Okay, so you please keep in mind, whenever they are giving variable limits, we are not focusing on these variable. So you need to focus on the given limits. So you always remember here the concept, if the limits are in terms of x means these are the y limits. Okay, whatever it may be, if the limits are in terms of x means it is y limit. If they are giving limits in terms of y means these are in terms of y means these are x limits. Means suppose the given limits are in terms of x means those are the limits of y. If the limits they are given in terms of y means those are x limits. So then we shall identify here. So if you look at your second integral limits 0 to x square, it is in terms of x square. X square means these are y limits. So identify y lower limit is 0 and y upper limit is x square. Similarly, x lower limit is 0 and x upper limit is 4. So suppose if you are getting confusion, you write at one side. So limits of y are varying from 0 to x square, and limits of x are varying from 0 to 4. Means here when they are giving variable limits, so first we need to integrate with respect to y, because first integral limits 0 to x square, these are limits of y. Therefore first we need to integrate with respect to y, then with respect to x. So your order of integration is first with respect to y, then with respect to x. Means we are not going to see this variable, we need to identifying the order of integration on the basis of limits. So first variable limits means you consider here the given variable limits are in terms of x square, those are the limits of y. So first we are integrating with respect to y. Therefore if you rewrite the given function, so integral 0 to 4, integral 0 to x square e power y by x into dy into dx. So I is equals to integral 0 to 4. So if you integrate with respect to y, okay, now we are integrating with respect to y. So y means x terms we are treating as a constant, right? Here what is integration of e power y by x? Here we are making use of the formula integration of ax into dx. It gives e power ax divided by a. Here a is the constant. Similarly, if you identify e power y by x means 1 by x acts as a constant. Therefore integration of e power y by x gives e power y by x divided by 1 by x, because 1 by x is constant and the limits are from 0 to x square into dx. Now let us simplify this. I is equals to integral 0 to 4. If you take x here, so denominator contains 1 by x. If you rewrite this, x into e power y by x, the limits are from 0 to x square into dx. In next step I am going to use these limits. Upper limit of y is x square and the lower limit of y is 0. So integral 0 to 4 x into x is constant and e power y by x. In place of y I am using the upper limit x square. So therefore you are getting e power x square by x minus, if we use lower limit, so x is constant again, so e power 0, because in place of y if you put lower limit you are getting e power 0 into dx. Therefore I is equals to integral 0 to 4. Here x square by x means x cancels, you are getting x into e power x minus x into e power 0. So e power 0 value is 1. Therefore x into e power x minus x into dx. Now this function we need to integrate with respect to x. So I is equals to, here for integrating x into e power x, so x is also a variable, e power x is also a variable. So therefore we shall use the formula integration by parts, that is integration by uv method. So u into v integration gives u into v1 minus u dash into v2 plus and so on. Means here u means your first function, v is the second function. So as per the I-let rule, so we are using I-let rule. It means inverse, logarithmic, algebraic, trigonometric and exponential. This is the order of considering first function and second functions. Here x, so x is algebraic function, right? X is algebraic function and e power x is exponential function. Therefore, algebraic function you are considering as a first function and exponential as second function. So therefore, integration of x into e power x into dx. So in place of u, you are having x, in place of v, you are having e power x. So let us integrate here u into v1. So u means first function, x as it is. v1 means integration of second function. Integration of e power x is e power x itself minus u dash. U dash means differentiation of first function. Differentiation of x gives 1, and v2 means integration of v1. So integration of e power x is again e power x. So therefore here if you take e power x as common, you are getting x minus 1. So e power x into x minus 1 is the integration of x into e power x dx. So let us use this directly. So therefore integration of x into e power x gives e power x into x minus 1 minus integration of x with respect to x gives x square by 2, and the limits are from 0 to 4. Now let us apply the limits here. So limits obviously we are going to use on x. Upper limit of x is 4 and the lower limit of x is 0. So I is equals to, so e power, so first let us use 4 in place of x, e power 4 into 4 minus 1 minus, directly you use the lower limit also for the first term. So then e power in place of x, if you use lower limit 0, you are getting e power 0 into 0 minus 1 minus, now on second term you apply the upper and lower limits. In place of x square, if we use 4, you are getting 4 square by 2 minus 0 by 2, it means 0. Then if you simplify this, I is equals to e power 4 into 4 minus 1 gives 3 minus e power 0 value is 1, right? So e power 0 value is 1, and 1 into minus 1 gives plus 1 minus 4 square is 16, 16 by 2. So if you simplify this, 3 into e power 4, so 1 minus 16 by 2, so 1 minus 16 by 2 gives minus 7. Therefore your final answer I is equals to 3 into e power 4 minus 7. So this is your integral value. So this is the method of calculation when they are giving variable limits. So once again, just I want to highlight this, because when they are giving variable limit, of course if the limits are constant, then we are going to identify the order of integration on the basis of x or y. We are going to decide on the basis of these variables dy and dx. But here when they are giving variable limits, if they are giving in terms of x means those are the y limits, if they are giving in terms of y means it is x limits. So here x, your first integral takes the limits 0 to x square. 0 to x square means it is in terms of x, therefore y limits. So therefore the order of integration is first with respect to y, then with respect to x. Then your obvious process of integration, if you follow and if you use the given limits, you are getting the final answer for the given problem. Okay, thank you.